Okay, so we are looking at our solution here from the previous problem, and we had 50 milliliters of 0.15 molar acetic acid, and now we're going to do some stuff to it. So we have that 50 milliliters of 0.15 molar acetic acid, and in this problem we're going to add 25 milliliters of water to it. Okay, so water doesn't do anything. All it does is change the molarity because, think about it, you add water, it's going to be less concentrated. Just like if you made a sports drink out of a sports drink powder and it was too sugary, too syrupy tasting, and you just added some more water. You diluted it. You made it a little bit less intense, and that's what we're doing with our acid. So there are two ways to do this problem. It's going to end up the exact same way that we did the first problem, but the easiest way to approach this is you just do the dilution equation or the titration equation, but it realizes that you're going to have a new molarity. Okay, so my initial volume is 50 milliliters, and then it had a molarity of 0.15 molar, and then my new volume, if I add 25 milliliters to it, is going to be 75 milliliters, and that's going to give me a new molarity M2. So that's the simplest way to approach it. And then you just divide both sides by the 75 milliliters. So 50 divided by 75 times 0.15. And so that's going to bring our new molarity to 0.10 molar. And so that's going to go down in that HA position. The other way to do it is if we start out with 50 milliliters of 0.15 molar, that is going to be 1 liter is 1,000 milliliters times 0.15 moles in 1 liter. Okay, and so that pulls out the moles that we have. 50 divided by 1,000 is 0.05 times 0.15 is 7.5 times 10 to the negative third moles of the acid. Okay, and you're like, Mr. Burr, that's not the same. I know it's not the same because we took our 50 milliliters and we added 25 milliliters of water, and so you would be dividing that by 0.075. So you take that 50 divided by 1,000, and I know the answer, I'm just showing it to you, times 0.15 divided by 0.075, and there you get your, whoops, what did I do that? What did I do there? Oh, I did it again. So 50 divided by 1,000 times 0.15. 50 divided by 1,000 divided by, oh, whoops, times 0.15 divided by 0.075. There's your 0.1. Okay, that took me forever. Well, I guess it's more time for you to watch the video. But either way, you get the 0.10 molar. So that is, you don't have to do both of these. This is like A, this is like B. I would say A is easier just because, you know, you plug into that M1, V1, M2, V2. But either way works. I don't care. And, you know, more importantly, on the AP exam, they're going to give you both. Okay? So we know that we got our Ka, we got H plus, conjugate base, A minus, we got HA, and so we know the Ka doesn't change. We didn't change the temperature. So it's 1.8 times 10 to the negative fifth, and then it's x squared, and then our new molarity is 0.10 molar. And to solve for the pH, it would be negative log of the square root of 0.1 times 1.8 times 10 to the negative fifth. And that's going to give me my pH. Now, if I don't miss my guess, if the concentration is less, the pH maybe should be more because it's not as strong. Let's see if that works out. Negative log, and I shouldn't be guessing, should I? I'm a chemistry teacher. But anyway, 0.1 times 1.8 times 10, caret, negative 5, boom. And in the original, we had 2.78, and in this one, we have 2.87. And so you see that as we get more diluted, that acid is just not as intense, and that pH starts to creep up. So the effect of diluting an acid or a base with water is the fact that it just gets less concentrated and therefore less intense. So acids will have a higher pH as they get more diluted, get closer to neutral, and bases will sort of back down to neutral, so they'll have lower pHs as you add water.